Hello dear friends, today I am going to talk about equivalence partitioning and boundary value analysis. Part 1. Equivalence partitioning. Let me start with equivalence partitioning. We will be going to see what you mean by the equivalence partitioning and the method. Equivalence partitioning is a method for deriving test cases. In this method, equivalence classes are identified such that each member of the class causes the same kind of the processing and output to occur. Equivalence partitioning divides large set of value into partitions. It expected to behave the same for all the values in the equivalence partitioning. Dear friends, I would like to ask you to note down this point that when you are partitioning large data into the equivalence partition, it is very important to remember that the partition should consist of the values which will be having the same behavior. As of we are not going to check or test all the values in this partition, maybe we are going to check or test only one or two values. So one or two values result will be representing the whole values which is there in the partition. Each test is representative of that partition. Sometimes equivalence partition not found in the domain. Let me talk about the certain benefits which is there, which we are getting from the equivalence partitioning. Definitely it will useful to the user, tester. It will helpful to the tester to complete the testing part in given time limit, so that because we are not going to test each and every case or the test case in that particular set. We are going to test the few cases which are representing the whole values in that set. So we can say that this method is useful to reduce the total number of test cases and to finite the set of testable test cases, still covering the maximum requirement. It is still we are getting the quality assurance that yes, test cases are valid and it is tested. In short, it is the process of talking all possible test cases and placing them into the classes. One test value is picked from each class while testing. We would like to see the example. In our academics, we are generating the grade sheet, and this grade sheet where the grades are awarded to the student which are mapped with the percentage. So I can say that if grade A is there, so the percentage of that student is in between 65 to 69. So I will be going to check if I entered any value between 65 to 69, I must be getting the grade A. So there is no need to check each and every value in between the 65 to 69. So this is what the use of the equivalence partitioning. Equivalence partitioning, we can also go with another example, simple example. If I am supposed to check the values, I can say that the input values which are between 1 to 1000. So I am supposed to go for the 1000 test cases, and which will be going to give me the valid test case, as well as we are also supposed to check some invalid data. So in all there will be so many test cases which we are supposed to test. But because of the equivalence partitioning, broadly we will be going to have the 3 test cases, and 3 test cases which will be covered the invalid data inputs as well as the valid input data. So using equivalence partitioning method, above test cases can be divided into 3 sets of the input data called as classes. Each test case is a representative of respective class. So in this example, we can divide our test cases into 3 equivalence classes of some valid and invalid data. Now we will be going to see test cases testing process for equivalence partitioning. As I have already mentioned that there will be the possibility of generating 3 test cases. We will be going to see how it is implemented to this given example. In this example, we are supposed to test the values from 1 to 1000. So we will be having the class of the valid data. So one input data class with all valid inputs. So we can say that pick a single value from range 1 to 1000 as valid test case. If you select other values between 1 and 1000, then the result is going to be same. So one test case for valid input data should be sufficient. So what I am trying to say that between the 1 to 1000, any value which I can pick and I can test it, so it is representing the rest of the values. If I say that 55 is valid, so I can say that other than 55, all the values in between 1 to 1000 all will be valid. As well as we will like to see that invalid data. So input data class with all values below lower limit, that is any value below 1 as a invalid input data test case. Then the another is that the input data with any value greater than 1000 to represent third invalid input class. So if any one value which is from the lower limit and the upper limit, if it is giving me the invalid output, so this means that our case is tested and it is giving us the right data. So using equivalence partitioning, we have categorized all possible test cases into 3 classes. Test cases with other values from any class should give you the same result. Now let me go with the certain question. So solved example over here. I have the multiple choice question over here. Given the following specification, you can see the condition. If you are less than 18, you are too young to be insured, so you will not be allowed for the insured. Whereas the age between 18 to 30, you will be getting 20% discount, as well as when there is age is greater than 30, so you are not eligible for discount. Now the question is that the 4 choices are given and we would like to ask you that which is falling into the same class. Now here the A 17, 18, 19, if we are considering the 17, 18, 19, these 3 input data which is not falling into the one class. So before going to this data discussion, we would like to know that what will be the, I can say that what will be the classes will be formed. So the classes which you are going to see over here, class 1 where the age is less than 18, not insured. Class 2, age is between 18 and 13, it will be the 20% discount. Whereas class 3, age is greater than 30, no discount. So here you can see that 17, 18, 90 is not falling in the class 1 as it is age is less than 18 for 17, but 18 and 19 are not coming into the class 1. It will be class 2 and class 3. In the similar manner, we can check with the other data, and after checking we can see to it that here we will be having this particular I can say that this is possible answer for means 18, 29, 13. These are the input data which is coming in the valid data set. So this is from the same class. So this is the solution where we can find out instead of checking all the values in between that, we can check the few values and we can say that these particular values are tested for the that software and the answer. I can say that the solution. So here we would like to conclude the equivalence partitioning, and we would like to start with the part 2. Part 2 which we will be going to continue with the second part of the video. So friends, thank you very much. Do some exercises at home. Thank you.